I am Dr.R.Jamuna, Associate Professor, Department of Computer Science, SR College. Multi-threading concepts in Java. Multi-threading is a very significant concept in Java. In this presentation, let us learn about multi-threading concepts. But before we proceed with multi-threading, let us understand what threads in Java are. Multi-threading programming is a conceptual paradigm for programming where one can divide the program into two or more processes which can be run in parallel. We will learn about the following topics in this presentation. What is a Java thread? What is a thread lifecycle? How can we create a thread? What is the significance of main threads in Java applications? Each and every process will have a main thread. A Java thread is the smallest independent unit of a program which contains a separate path of execution. A thread in Java is created and controlled in the java.lang package. By default, it is present in the java.lang package. Java thread lifecycle. When we create a thread, it will have a lifecycle. A thread can live only in one of the different states at any point of time. Typically, a thread will be in a new state or a newborn state called init state. When it is created, then it moves to the runnable state. In the runnable state, it will be present in a queue depending on the priority to get the processor. And then it goes to the running state when it gets the processor. Finally, the thread will end in a terminated state. In between, a thread can have a waiting state or a blocked state, which can iterate between the runnable and the running state. On 3 instances, a particular process will go into the blocked state. Either it will be suspended by the user and after a certain interval of time, it will be resumed by a resume function will bring back the process to the runnable state and then to the running state again. In another scenario, we can just make the process sleep for certain milliseconds and then it can once again be revived from the sleeping state. Then as usual, it enters the runnable and the running state. When it goes to the sleep state, it comes out of the runnable queue. Then it once again enters the runnable state to move on to the run state. And certain other conditions, a particular process will go to the wait state until an event is completed. And then by a particular notify method, it can just come back to the runnable and the running state. In certain other conditions, a particular process will go to the dead state. Whenever a process is in the runnable state or the running state, it will be called as an active thread. From the active state, it can either move on to the dead state when it is no longer needed to complete the task. Sometimes it can just move from the init state itself to the dead state. Or in the blocked condition also, it can, from the blocked state also, it can move on to the dead state. Under all other conditions, the thread can just move on a normal cycle, gets a processor, and then it completes, then it successfully completes the task of getting the processor. The thread life cycle is elaborately shown here. From the new state, it can go to the runnable state, and then it can go to the terminated state after a particular time interval. It will successfully complete the task under normal conditions. Or sometimes it occurs a lock and go to the blocked state, and then it can come back from the blocked state to the runnable state and running state. It can move on to the running state. It can go to the waiting state from the runnable state. It can wait for any other application to complete and then it can come on to the queue, join the queue again. It can also go in for timed waiting and it can just come back from the timed waiting state or the sleeping state to the runnable state again. States of a thread. A new state. In the state, the new object of a thread is initiated. A new thread begins its life cycle. In the state, it remains here until the program starts the thread. We can also say that the thread is born in the state and that's why it is called as a newborn state of a thread. Runnable state, once a thread is created, we can start. By the start method, the thread goes to the runnable state. The thread stays in the runnable state until it is executed. After starting the thread, it comes under the runnable state. Running state. In this state, the thread is running, which means it is executing the run method, and we can have the yield method by which we can just send a signal and then to bring back the runnable state again. Waiting state, when a thread enters a state of inactivity such that it is not performing any action, it is known as waiting state. In this state, the thread waits for some other thread to get completed, give back the data or the processor, or it is sleeping, or it is blocked under certain conditions as discussed above. Terminated state, when the thread has completed its task successfully after execution, it is known as terminated state. What is the need of a thread and why do we use threads? Using threads or a multi-threading concept, we can perform asynchronous or background processing. We can increase the responsiveness of GUI applications to take advantage of multiprocessor systems, to simplify programming logic when there are multiple independently runnable entities. Understanding threads again, let us understand the threads with the help of an analogy. Suppose we want to download an image from the server. Here, the threads are typically used when we have to perform a long-running application or a long-running operation. Downloading an image seems to be a simple operation, but it can be a long-running operation when it is dependent on the network speed. When downloading an image, we create a new thread, and in the background, we still start fetching the bytes for some other process from the server, and in the running state, the thread is continuously fetching the data. There can be a state called waiting state when the network connection gets disconnected. When the thread can wait until the network connection gets re-established, and it will get terminated when the image is properly downloaded. Creating a main thread. We will now look into the process of creating a thread. If you want to create a thread, you need to understand the purpose of creating the thread. By default, we can have a main thread in our application that is represented by the main method. Whenever we run our Java application, we write our code in the main method, and the code in the main method is executed as the main thread itself. Therefore, the main method will contain the instructions within it, and these instructions will be executed as part of the main thread in a sequence. Now, if a long-running operation takes place within the main thread itself, it can take the time causing the low written instructions in the main thread to be blocked. Since the instructions are blocked, and the operating system will start giving messages to the user that the application is not responding, and it will also ask the user to wait or kill the application. Therefore, a long-running application, we need to create a separate entity or a load from to reduce the load from the main thread. Creating a thread by software instructions through coding, we have to make a very clear declaration. One, by extending the thread class. Second one, by the runnable interfaces. Using thread class, public class, thread, the standard name, extends, some class name, implements, runnable. Second one, in the runnable interface, public interface, runnable. Extending a thread class, with an example, let us demonstrate. The class should extend Java thread class. The class should override the run method. The functionality that is expected by the thread to be executed is written in the run method. Void start method creates a new thread and it makes it runnable. Void run method, the new thread begins its life inside this method. Example, public class, some thread name. I'm putting it as thread1, extends thread, the standard class. Public void run, the standard method. System out the println, thread is running. You can just print something. Public static void main string arguments array, thread, some object name. I'm putting it as obj. My thread class name is thread1, so thread1 obj is equivalent to new of thread1 obj.start. This is one way of extending the thread class. Runnable interfaces. We can also create threads by implementing runnable interfaces. The class should implement the runnable interface. The class should implement the run method in the runnable interface. That is, public class thread1 implements runnable. Public void run. System out that println thread is running, something you can print. Public static void main string arguments array. Thread T is equivalent to, T is the object name here, new thread of. the standard thread class in which I'm just enclosing the thread class I have created. New thread 1. Then object.start. T.start is exactly the way to start the thread. Synchronization of threads. In many cases, concurrently running threads share data and two threads try to do operations on the same variables at the same time. This often results in corruption of data as the two threads or the two processes try to operate on the same data at the same time. A popular solution is to provide some kind of lock parameter. Only one thread can adhere a particular lock at any particular time. This can be achieved using the keyword synchronized. By using the synchronized, only one thread can access the method at a time and a second call will be blocked until the first call returns or while is called inside the synchronized method. Deadlock in threads. Whenever there is multiple processes contending for exclusive access to multiple locks, there is a possibility of deadlock. A blocks the resource that B wants and B blocks the resource that A wants unknowingly. A gets blocked by B and B gets blocked by A and so on. Something like this, one or more processes of the threads can get blocked or can face the problem of deadlock. A set of processes or the threads are said to be deadlocked when each one is waiting for an action that only one of the others can perform. In order to avoid a deadlock, one should ensure that when you acquire multiple locks, always acquire the locks in the same order in all threads. The following are the references. Thank you for listening.